Let us understand laws of reflection. When I say laws of reflection, that means there are multiple laws. The first part of the laws of reflection says we will understand using the plane mirror. Here is a plane mirror and here is a point source of light. When the ray falls on this point on the mirror, it reflects back in this direction. If we draw a normal at the point of incident, then all the three are going to lie in the same plane. If we draw a plane across these three lines, they are going to lie in this plane. This completes our first part of the law of reflection. It does not tell where the reflected ray is going to be. It only tells that all the three, the incident ray, the normal and the reflected ray, lie in the same plane. The reflected ray can be this one as well. To define uniquely which one of them is going to be the reflected ray, we need the second law. We will understand that in a bit, but before that, let us bring our 3D models. And if I ask you a simple question, in which of the two models one of the ray is not planar with the other two? By looking at it, if you guess it, you are going to be only 50% right. But if we rotate this model, now you can exactly say in this model the ray is out of the plane, and in this model all the three lie in the same plane. This is what exactly happens with light. This does not happen with light. The second part of law of reflection says that the angle of incidence and angle of reflection are equal. Here is a plane mirror and here is a point source of light. When the ray falls from here to the mirror at this point, it reflects back in this direction. If we draw a normal at the point of incidence, this is our normal. The angle of incidence is the angle between the normal and the incident ray is called the angle of incidence. This angle is angle of incidence. The angle between the normal and the reflected ray, this angle is called angle of reflection, and these two are exactly same in magnitude. That is what is the second part of law of reflection says. What about the other two angles? This angle between the reflected ray and the mirror and the incident ray and the mirror, these two angles are also same, but they are simply not angle of incidence nor angle of reflection, and these angles are not connected to laws of reflection in any sense. The only reason these two angles are equal because of the geometry. If we take this mirror as a plane line, the sum of the four angles, this one, this one, this one and this one, has to be 180 degree. And if these two angles are equal, this has to be equal, the other two one. So these angles are equal, but they are not connected to laws of reflection, and they are not called incidence, angle of incidence or angle of reflection. Here is a plane mirror and associated rays. Let us understand the laws of reflection in such a way that we will never forget it. Here is a smooth plane and here is a ball. If we throw this ball on the plane, it reflects back in this direction. If we trace the path of the ball, this ray can be thought as an incident ray and this ray can be thought as a reflected ray. If we draw the normal at the point of incidence over here, this angle can be understood as a reflected angle of reflection, and this angle can be understood as an angle of incidence. This is exactly what happens with light. If we draw a plane across the motion of the ball is going to lie in the same plane. That is a perfect analogy for understanding laws of reflection. But what will happen if we rotate the ball and throw it on the smooth surface? There is a twist in the story now. It will come in the plane, but it will bounce back in a different plane. If we draw the incident plane and the reflected plane, you can see that it is going out of the plane after reflection. Because there is a rotation in the ball, it is going out of the plane. That is the reason it is very difficult to play a spinning ball. This does not happen with light. Light is traveling at a very high speed. It does not have time to change its plane of motion. It remains in the plane of motion in which it is coming on, and it maintains the plane of the motion. Since we have understood the law of reflection using plane mirrors, does this law of reflection is valid for any other kind of reflection as well? To start with, here is a curved mirror and here is a point source of light. When the ray starting from here strike at this point, it reflects back in this direction. Does law of reflection is still valid over here as well? To understand that, let us draw the normal first. So if you draw the normal, the angle between the incident ray and the normal, this angle is angle of incidence, and angle between the normal and the reflected ray, this angle is angle of reflection, and these two are also same. That means the laws of reflection are valid for any kind of reflection, not just for plane mirrors. Let it be a spherical or cylindrical object, the law of reflection is always valid. If you have still some confusion about this law, let us bring this whole model towards this point and see this exactly behave like a plane mirror. Actually, what happens is each point along this curved mirror behave as a small plane mirror.